Hello, this is another video as part of the video series on current electricity. So in this video, we are going to look at internal resistance, loss voltage, and efficiency of the cell. Efficiency of the cell. Okay. Now, there is something called internal resistance. That is the opposition to the free flow of current that is offered by the voltage source itself. So if the cell has internal resistance, it's going to affect the efficiency of the cell. Internal resistance is the opposition to the flow of current by the voltage source, which is the battery of the cell. It is the loss of potential difference. It is the loss of PD per unit current in the circuit. It is the loss of PD per unit current in the circuit. So the internal resistance will cause a loss in the potential difference. So which means the E.M.F of the cell will be higher than the terminal PD, which means when you connect a voltmeter, so what the voltmeter will read will be different from the E.M.F of the cell. So if the cell does not have internal resistance, then the terminal potential difference should be equal to the E.M.F. But if the cell has internal resistance, there will be a kind of loss in the voltage, so which is called the loss voltage. So let's use a cell to analyze this, a circuit, sorry, to analyze this. Let's say you have this circuit and you have a resistance connected in series to it. And you have an ammeter here. Okay. So if the E has an internal resistance R and it is connected to a resistor R and a current I flowing through it. Okay. So the E.M.F E will be equal to the terminal PD, which is the voltage that, or the potential difference that the voltmeter that is connected across this resistor will read. That V, that voltage, is the terminal PD plus the loss voltage. There'll be a kind of loss due to the internal resistance. Okay, so the E.M.F, the terminal PD, which is the potential difference that this voltmeter will read, is basically the current that flows through the circuit multiplied by the resistance. So the E.M.F will then be equal to IR plus, and the loss voltage is the current multiplied by the internal resistance R. So E, the E.M.F equals the terminal PD plus the loss voltage. And the loss voltage is the current multiplied by the internal resistance, and the terminal PD is equal to the current multiplied by the resistance that is connected in series to it. Okay? So if you make I the subject of the formula here, then you have I into R plus R. So it means I, the current that is flowing through the circuit, will be the E.M.F divided by the total resistance plus the resistance offered by the cell itself. Okay. So if you remember from Ohm's law, in the previous videos, we established that the current will be V divided by R, right? So the V in this case is basically the E.M.F because there is no internal resistance, and the R is the total resistance. But if there is internal resistance, then the E, this voltage is not the terminal PD because it's not going to be smaller than the E.M.F. So it's going to be the E.M.F the current would then be the EMF divided by the total resistance plus the resistance that is offered by the cell itself. Okay. So that's that on the internal resistance. The loss voltage. I've given you the formula for that already. Loss voltage is current multiplied by the internal resistance. Now let's go to the efficiency of the cell. The efficiency of the cell will drop because it's not going to deliver the full voltage that is expected. So how do we determine the efficiency of the cell? The efficiency, the efficiency of any machine or anything is basically the work output divided by the work input. So what is put inside is more than what we get out. So what we get out, the voltage that we get out is the potential difference that the voltmeter will read. So which is the terminal PD. But the voltage input is basically the EMF of the cell. So this is the formula for calculation. If we want to take it to percentage, you multiply by 100. So the efficiency of the cell will then be equal to the terminal PD V divided by E. And you know that V is IR, and we know we've established that the EMF is IR plus IR. Remember from previous page. So the efficiency will therefore be equal to IR over I can factorize R, the I out. Then I can cancel this I, multiplied by 100, right? 100. So the efficiency of the cell will be R over R plus R multiplied by 100. So if you have to calculate the efficiency of the cell, you can use that formula. We know the resistance that is connected in series to it, and you know the internal resistance. Okay? So let's look at some examples. The first example you have is that a battery, example 1. A battery of EMF 12 volts and internal resistance 1.5 ohms is connected to a 4.5 ohm resistor. You have to calculate the total resistance in the circuit, the current through the circuit, the loss PD, and the PD across the resistor. So let's quickly draw a diagram to illustrate this. So we have a resistor of 4.5 ohms connected to a battery of 12 volts, and the internal resistance of the battery is 1.5 ohms. So you have to determine, so this is how we have, let's say you have an ammeter that reads the current here. You have to determine the total resistance in the circuit. So this is easy. The first part, total resistance, R total will be the resistance that is connected to it in series plus the internal resistance that we have there. And that will be 4.5 plus 1.5. So the total resistance in the circuit will be 6 ohms. See, that's easy enough. Then B, you have to determine the current through the circuit. So if you recall the formula for current, I is equal to the EMF divided by R plus R. So which is the voltage source divided by the total resistance. So, and I will be 12 divided by R plus R. So that's 4.5 plus 1.5. So I will be 12 over 6, and that will be equal to 2 amps. Okay, so that's the current that is flowing through it. So the next one is the PD, the loss PD, the loss voltage. So what was the formula for loss voltage? You recall? Loss PD is equal to I multiplied by a small letter r. So that will be equal to the current 2 multiplied by 1.5, which is the internal resistance. And that will give you 3 volts. Okay. Then the PD across the resistor. So this is 4.5. The PD across the resistor. So that's the terminal PD, basically V, and that is IR from Ohm's law. So that will be current 2 multiplied by 4.5, and that will give you 9 volts. So if you look at it, this voltage plus the loss voltage, this capital V plus the loss voltage, the small v, must be equal to the EMF, the total EMF. So that should be 9 plus 3, and that should be 12, and the EMF is 12. Okay, that makes sense. So let's look at the last example. So in this example, you have to consider this circuit that we have here. In the circuit, you have 2 resistors connected in series, and you have a cell of 12 volts with internal resistance of 3 ohms. You have to calculate the current. So to determine the current, you know I is E over R plus R. So this R is the total resistance that is connected to the circuit. Basically, I can call it RT if I want, because now I have more than one resistor. So I will therefore be equal to, because these 2 resistors are connected in series, my RT will be R1 plus R2. So if this is R1 and this is R2, okay, so RT will be 6 plus 4, which is 10 ohms. Now RT is 10 ohms. Then I can determine the current by substituting what I have. E is 12, RT is 10, and R and small letter r is 3. So I will be 12 over 13. 12 over 13 is 0.92, I think. 0.92 amps. Okay, so that's the current. Now you have to calculate the PD across the 6 ohm resistor. The PD across the 6 ohm resistor, V across the 6 ohm, will be the current through the 6 ohm multiplied by the resistance of the 6 ohm itself. And that will be the current through the 6 ohm is the same current, because this current I is the same current that will flow around circuit, because everything is in series. So that will be 0.92 multiplied by 6. 0.92 multiplied by 6, and that gives you 5.52. 5.52 volts. And the last question, you have to calculate the efficiency. The efficiency of the cell, recall, so that's the C part. The efficiency is equal to R divided by R plus R multiplied by 100. Recall the formula where we use the terminal PD divided by the E.M.F. Okay, so the total resistance that is connected to it is this R, and this is its own internal resistance. So we obtain the total resistance that is connected to it as 10. So that will be 10 over 10 plus 10 is the own internal resistance is 3. 3 multiplied by 100. So that will be 10 over 13 times 100. So 10 over 13. That should be 76.9%. So that's the efficiency of the cell. Okay, so that's it for the video, and I'll see you in the next one. Bye-bye.